So the next is binary up down counter. So this is a circuit which is going to perform up counter as well as down counter. So what we discussed in the previous video with respect to the D flip flop, this is up counter starting from 0 to 7, 0 1 2 3 4 5 6 in a rising manner. So it's up counter. So this circuit can be used both for up counter as well as down counter. It can perform both up counter or as well as down counter. Down counter in the sense starting from 111, 7 6 5 4 3 2 1 like that. Okay, down counter. So they have given a transition graph. So it's a clockwise direction or anti-clockwise. If it is in clockwise direction, it's upward. If it is an anti-clockwise direction, it's a downward. So they are written here. This is upward. U refers to up, T refers to down. 0 0 1 2 0 0. So 111 to 110 like this. So up down counter. So these are the equations. So these equations are written based on this circuit diagram. Look at this circuit diagram. So the output of this will be du. So the output of this will be from A, right? Du XOR A. Right. The same thing they are written here. A XOR U plus D. This is OR gate, right? So this will be plus. So this will be U plus D. Okay, this will be U plus D. U plus D XOR A. The same thing. A XOR U plus D. So similarly here this will be a connection is from this is D AND gate. The connection is from A bar. So the output of this will be D A bar, and output of this will be one connection is from A. So U A. Okay, combining this D A bar plus U A here. This is what they have written here. D A bar plus U A XOR one more connection is from B XOR B here. So it's based on this. So they have written these equations. Okay, so you need to learn this circuit diagram. Based on this circuit diagram, they have written these equations. Okay. So when does this particular circuit is going to perform up counter as well as down counter? So you can notice here U refers to up, D refers to down. Okay. So whenever look at this, whenever U is equal to 1, it is going to perform D is equal to 0. Whenever U is equal to 1 and D is equal to 0. So whenever U is equal to 1 and D is equal to 0, so this particular circuit diagram is going to perform up counter. Okay. So what we discussed in the previous video, this is up counter. Okay. So whenever U is equal to 0 and D is equal to 1, this is going to perform down counter. So whenever U becomes 0, this particular equations, you just assign U is equal to 0, like make it 0 0 0. Wherever you find U, make it 0. So that is going to perform that is going to perform these three equations. If you assign 0 to these equations, that is going to perform these equations. A XOR 1 B XOR A bar C XOR B bar A bar like this. Okay. So you can notice here A changes the state every clock cycle. These are the equations for down counter. So you need to concentrate on this down counter. So what is there written? A changes the state every clock cycle. Look at here. So here it is 1, next it is 0 1 0 1 0 1 0. So this is A, this is B, this is C. So A changes every clock cycle. So A, they are written A bar. Why they are written A bar? So 1 is there, next it will be 0, next it will be 1. So it is getting inverted. So they are written A bar. Next, B changes states when A is equal to 0. B changes its state when A is equal to 0. Means here it is A bar. So A is equal to 0 means A bar is 1. B changes its state when A is equal to 0 means A is equal to 0 means A bar is equal to 1. So B will change whenever A is equal to 1. So look at here. Here B is 1. B is changing from 1 to 0 means A is 1 here. So B is changing from 0 to 1 means A is 1 here. B is changing from 1 to 0 means A is 1 here. 0 to 1 is A is 1 here, like this. Similarly, C changes the state from B and A is equal to 0. Here it is B bar and A bar, means B and A is equal to 0 means B bar, A bar means 1 and 1. So C changes its state when both A and B are 1 and 1. Look at here. C is 1 here. It changes from C 1 to 0 means both A and B are 1 and 1. So look at here. C changes from 0 to 1 but both A and B are 1 and 1. So this is what they are given. So just you need to learn the circuit diagram, just you need to write this transition diagram, this table and these equations when up down counter, if they ask for binary up down counter. That's it. So then we go with the next. This is circuit loadable counter and count enable. So we have two more two more concepts here. One is loadable and another one is counting. So look at here. This is a flip-flop. This is a 3-bit flip-flop because look at this number 3. 3-bit D flip-flop. So rather than writing the whole thing, they are written like this, D flip-flop. You can notice here we have two more inputs. One is count. CT refers to count. LD refers to load. And clear. You know the clear. What does clear do? So whenever clear is pressed, all the flip-flops will be clear to 0 and load with 0 whenever the clear is pressed. So you can notice the clear is bubble, having a bubble. So clear when it is 1, so nothing will happen here. When it is 0, this 0 will be converted to 1 by this bubble and this flip-flop will be remove everything and set to 0. So clearly 0 idre 1 ಗೆ ಕನ್ವರ್ಟ್ ಆಗಿ ಎಲ್ಲ ಫ್ಲಿಪ್ ಫ್ಲಾಪ್ಸ್ನು ಎರೇಸ್ ಮಾಡಿಬಿಟ್ಟು 0 ಲೋಡ್ ಮಾಡುತ್ತೆ. If it is 1 will be converted to 0 and flip-flops will be nothing will be performed. Nothing will be performed in the sense no changes will be performed. Okay. So if you want to activate clear, what is the data you are supposed to pass? You are supposed to pass 0. Why 0? 0 will be converted to 1 here because of this bubble. So then we have two more inputs. One is load and one more is what is that? Count. Okay. So what does this load, what does this count is going to perform? Let me see. So look at this table. Whenever clear is 0, no matter whatever the load might be, whatever the count might be, it's don't care. It will set all the flip-flops to 0, 0, 0, 0. Because clear means it will clear everything, whatever the data which is present with the flip-flops and set it to 0. That's it. Okay. Now clear is 1. Now clear in the remaining 3 transactions, clear is 1 means clear is not going to affect the flip-flop. Next we need to concentrate on load and count. Here load is 1. Load is 1. Look at this circuit diagram now. Here we have a multiplexer, 3 multiplexer. We have 3 flip-flops, A flip-flop, B flip-flop, C flip-flop. All the 3 flip-flops are made up of D flip-flops, D, A, D, B, D, C. All of them are connected to a clock. So all are positive triggered. Okay. So we have a load here. This is a multiplexer. This is a 2:1 multiplexer because why we call it as 2:1? We have one output, 2 input. This is one input, this is one input. One input is D, another input is from C. Here also 2 inputs. One is DB, another input is from B. Here one input is from DA, another input is from A. So what is the role of load? So load is something like a control input. Remember the multiplexer. What is the role of a control input? Control inputs are those which will decide which input need to be passed on to the output. You remember. So there, if it is 0 to 7, 8 inputs means there will be 3 control inputs, and those 3 control inputs will decide which input need to be passed on to the output. That is what the multiplexer. Here 2:1. So 2:1 multiplexer means 2 inputs, 1 output, 1 control input. One control input is going to decide which input need to be passed on to the output. We have 2 inputs. So which input, either this input to be passed on to this multiplexer or this input to be passed on to the multiplexer will be decided by this load. Load is a control input here. Okay, data input. So the same thing with respect to 3 flip-flops here. So load, whenever the load is 0, LD, what is this? Load is 0. Whenever the load is 1. Load is 1 means active. Whenever the load is 1, it will accept the data from D, data input, DA, DB, DC. So they are written here, DC, DB, DA. So whenever the load is 1, so we are least bothered about count, CT, whatever the count might be. Whatever the count might be. Whenever the load is 1, it accepts the data from here, DA, DB, DC. Okay, so that is why the next state will be DB, whatever the data which is present with respect to DA, DB, DC will be the next state whenever the load is 1. Okay, so whenever the load is 0 and count is 1, okay, what is the action to be taken? Present state plus 1. If the present state is 0, 0, 0, the next state will be 0, 0, 1. Present state plus 1. Present state is 0, 0, 1 means the next state will be 0, 0, 1. If the present state is 0, 0, 1 means next state will be 0, 1, 0. That's it. Count. Whenever the count is 1, load is 0. So it won't accept, whenever the load is 0, it won't accept the data from DA, DB, DC. It accepts the data from C, B and A. Okay. C, B, A contains the present state. Okay. Next it will, count will be 1. Next it will count to the next state. If the present state is, if the flip-flop contains 0, 0, 0, count is 1, then it will be, next state will be 0, 0, 1. If the present state is 0, 0, 1, next state will be 0, 1, 0 like this. Count will be active. Load is inactive now because load is 0 here. When the load is 0, it won't accept the data from data DA, DB, DC. DA, DB, DC in the accept ಮಾಡ್ಕೊಳ್ಳಲ್ಲ. Load 0 ಆದಾಗ. Load 1 ಆದಾಗ DA, DB, DC ಇಂದ accept ಮಾಡ್ಕೊಳ್ತಾರೆ. Data input ಅಂತ ಹೇಳ್ತೀವಿ. Clear? So now the count is 1, load is 0. So in such a case, present state plus 1. If the present state is 0, 0, 0, the next state will be 0, 0, 1. If the present state is 0, 0, 1, next state will be 0, 1, 0 like this. Okay. If both load and count both are 0, 0 means both are disabled, then it retains its present state, CBA. Whatever the data which is present in this flip-flop, it will retain, no change. Whatever the data which is present in this flip-flop will remain as it is. No operation will be performed, so nothing changes will occur. So this is what. So whenever the load is active, it accepts the data from DB, DC, DA. So they are written DB, DC, DA. Whenever load is 0, count is 1, so the action will be present state plus 1. So whenever the load is 0 and count is 0, both are 0, 0, so it remains in the previous state. It retains its previous state. Okay. So whenever the clear is applied, so it just clears all the flip-flop and set all the flip-flops to 0. So this is the loadable counter and count enable. Okay. So based on this circuit diagram, they have written the 3 equations here. This is with respect to A plus means with respect to this, B plus means with respect to this, C plus means with respect to this. Okay. So you can notice here. So load bar. So load means 1. Load bar means 0. So whenever load is 0, accepts the data from A. A means from the previous state. B, previous state. C, whenever the load is 0, say load bar.